Welcome back. Synchronous replication in master-slave. Asynchronous replication in master-slave architecture allows the master primarily server, which is a primary server, to process and commit write operations without waiting for confirmation that the data has been successfully replicated to the slaves, which are the secondary servers. The master sends data changes to the slave servers, but it does not wait for their acknowledgement before confirming the write operation to the client. This allows the master to handle writes more quickly, but can introduce potential lag between the master and slave. So let's talk about how the master slave asynchronous replication work. So let's say that we have the client or the server trying to send a request to trying to send a write operation, which is insert, update, or delete to the master server, okay, or to the master database. And the master server processes the write request and immediately updates its own data store. It acknowledges the write requested to the client as soon as the local transaction is committed without waiting the replications to the slave. So it will send back a response. After that, the master asynchronously sends a changes or the changes to the slave servers. After the write operation has been committed, the slaves apply these changes when they receive them. So when the server tries to send again make a write request, the master, once the master approve the transaction, it will send it back, and it doesn't need any acknowledgement from the slaves. And then later, the master replicate all the data to the slaves. This can represent like a replication lag, because since the replication happens asynchronously, there is a delay between the time the data is written on the master and when it comes available on the slave. This means that the slave may not always have the most up-to-date data. Let's talk about some key characteristics of asynchronous replication, because it's really important to talk about them. The first thing, which is, oh no. The first thing would be the eventual consistency. In asynchronous replication, the master and slave are not always consistent at the same time. The data on the slave eventually becomes consistent with the master, but may be a lag between the two. This is known as eventual consistency. Also, there is the no waiting for slave acknowledgement, and this is the main difference between synchronous and asynchronous replication. So the master server does not wait for the slave confirm replication. This significantly reduces write latency, as the master only needs to handle its own data commit, allowing it to process writes faster. Number three, we have what is called a replication lag. So depending on factors like network speed, workload, and replication frequency, there can be a time delay between when data is written to the master and when it appears on the slave. This replication lag can vary from milliseconds to minutes. The last thing that we need to talk about, which is the data availability trade-off. Asynchronous replication prioritizes performance and availability over immediate consistency. If the master fails before the data is replicated to the slave, there is a risk of data loss. So there are some advantages, or there are multiple advantages of asynchronous replication. The first thing that we need to talk about, which will be the improved write performance. Okay, so let's remove this away like this. Yeah. So since the master does not wait for the slave's acknowledgement, writes process are way more faster. This makes asynchronous replication well suited for write-heavy applications where performance is priority. Number two, it's great when it comes to scalability because asynchronous replication is more scalable than synchronous replication. Like adding more slave servers does not impact the write performance of the master because the master does not have to wait for multiple slave acknowledgement. Number three, it reduces network dependency because since replication occurs asynchronously, the master can continue functioning without being slowed down by network delays or latencies that may affect communication with the slave servers. This makes asynchronous replication more robust in environments with unreliable networks. Number four, it increases system availability because asynchronous replication minimizes the chances of write bottlenecks. Even if the slave is down or slow, the master can continue accepting write operations. The data can be replicated to the slave once it's available again, making the system more resilient to network and server issues. Number five, in geographic distributed systems where network latency between master and slave is higher, asynchronous replication is preferred. The master can continue functioning without waiting for potentially long network round trip times between distant regions. Also, the asynchronous have some disadvantages. Let's try to talk about them. The first thing we need to talk about it, which is the risk of lost data. Let me make this quite wider here. So, if the master fails before the data is replicated to the slave, any changes that have not yet been replicated may be lost. This is a significant risk for critical systems where every transaction is important, such as financial transaction and systems. Number two, which is eventual consistency. So there is always a lag between the master and the slave, meaning that the data on the slave might not always be current. This can lead to inconsistent reads, especially in systems where clients read from both the masters and the slave. Number three, which is complex failover mechanisms. In the event of master failure, promoting a slave to a new master can be quite challenging because the slave may not have the most up-to-date data. A manual or automated process may be required to identify how much data is missing and recover the system in the best way possible. And we say also there is the fourth thing, which is application lag impact on analytics, because application or queries that depends on near real-time data such as reporting or analytics may receive outdated data from the slave due to replication lag. This can be problematic in scenarios where up-to-date information is quite critical. So let's talk about in conclusion. Synchronous replication in master-slave database architecture is an effective way to improve system performance and reliability by allowing the master server to handle write operations without waiting for replication confirmation from the slave. While it introduces the risk of data loss and replicating lag, it is ideal for applications that prioritize write performance and can tolerate eventual consistency. It is especially useful in systems where high available geographical distribution and write-heavy workloads are important factors. So that's it for this video, and see you in the future.